physics of how rainbows form. So first I'm going to talk about refraction and dispersion. So refraction is the bending of light whenever it goes from one medium to another that has different densities. So for example, let's say there's a glass triangular prism and you shine a beam of white light at this prism at an angle that's not parallel to the normal line, which the normal line is the line that's perpendicular to the surface. So if you shine a beam of white light at the prism at an angle that's not parallel to the normal line, it's going to enter the prism, it's going to bend, it's going to refract. Bending of light is called refraction when it passes through one medium that's denser than another or less dense than another. And whenever it exits out the prism, it's going to move away from the normal line. So before it goes through air right here, and then glass right here. Glass is denser than air, so it moves towards the normal line when it moves through the glass, and then whenever it exits the glass back into a less denser medium, it moves away from the normal line. So the reason why that happens, I'm going to give you an illustration. Let's say you're cutting grass. And this is a sidewalk. And this is grass. And let's say you're pushing a lawnmower in the sidewalk. Now, you're moving it in a straight line. But whenever this first wheel hits the grass, it's going to bend its path of motion. It's going to curve it. That's because it's slowing it down. So whenever this lawnmower hits the grass, the first wheel hits the grass, it's going to curve the path of its motion. Same thing happens whenever you shine white light or any light into a denser medium. You're going to slow it down. Like let's say here's a prism. It's going to cause it to curve its path. It's going to slow it down and curve its path. And let's say if the lawnmower was in the grass and you moved it to the sidewalk, it would curve away from the normal line. So whenever you push the lawnmower into the grass, it's going to curve towards the normal line, towards it. And here's the normal line here. You're pushing the lawnmower out of the grass to the sidewalk, it's going to curve away from the normal line. So that's refraction. Let's talk about dispersion. So you may have seen Pink Floyd before, their album cover for Dark Side of the Moon. It shows a prism with white light entering it at an angle that's not parallel to the normal line. And by the way, if it is parallel to the normal line, it's not going to bend. You can imagine that by pushing a lawnmower from the sidewalk into the grass at parallel to the normal line, and it just won't bend. It'll slow it down, but it won't bend it. Anyway, Pink Floyd's album cover, it shows white light entering a prism, and then it shows it breaking up into its colors. So, white light is made up of every color. Isaac Newton proved that in the 1600s. He got a prism, and he shined white light through it, and it broke it up into its colors. Then he got a second prism like this, and shined it through it, and it brought the colors back to white. So he showed that white light is made up of every color of the visible light spectrum. Before Isaac Newton proved that, people thought that uh, color, that dark black was just a mixture of every color, and white was the absence of color, and that darker color is it's just more colors mixed together, and the lighter color is it's colors uh, that has not much mixture, and that they thought that prisms gave white light color until Isaac Newton got the second prism, shined the broken up spectrum into the second prism, and it brought it back together, and it showed that white light was made up of every color. So anyway, let's talk about why does white light disperse to all of its colors. So let me go back to red. It moved away from the normal line. And this looks like Pink Floyd album cover. So the reason why is, let's go back to the scenario with the lawnmower and the sidewalk and the grass. Here's the sidewalk. Here's the grass. Here's the lawnmower. Now instead of the lawnmower having 4 wheels, let's say it has 6 wheels on each side. It's kind of an odd example, but just bear with me and imagine it. So here's the lawnmower with 6 wheels on each side. If it was to enter the grass at an angle not parallel to the normal line, it would curve at a greater angle. The angle of refraction would be greater than the 4-wheel lawnmower. And if it was a 2-wheel lawnmower, the angle of refraction would be less than the 4-wheel lawnmower. Similarly, red light if you think of light as a wave, here's what red light kind of looks like. It has a long wavelength. And blue light has a short wavelength. So, for the same distance, there is more wave crest for blue light than there is red light. So it's kind of like more wheels are entering into a denser medium whenever it goes from here to here. So the angle of refraction is greater than the red light because there's less crest per given distance for the red light. So that's refraction and dispersion. Now let's talk about rainbows. Let's say there's a raindrop like this, and white light enters it right here. Let me draw this more horizontal. So it enters it right here. Because the raindrop is made of water, it's more dense than the air. So as it passes through the air and then into the raindrop, it refracts, it bends. And then it reflects off the back right here. And then and since it's going from a denser medium to a less dense medium, it moves away from the normal line, which is this right here. So before it moved toward the normal line, then it moved away from the normal line. So let me redraw this better with different colors. So that's white light right here. It's going to refract and disperse. And then it's going to reflect. then it's going to refract again. Now, this is just light coming in right here. White light entering one raindrop right here. Now let's say it entered right here. The same thing's going to happen as before, except it's going to be different. It's going to be more like this. Like that. So it entered right here and exited like that. Whereas before it entered right here and then exited like that. Similarly, if you could imagine white light from the sun hitting every point of the surface of the front of the surface of the raindrop, and let's say the raindrop was like this, let me draw this better. Make it a mess. Let me erase some of this. Let's say I'm going to draw a curvature to the raindrop like this. And there was white light entering right here like before, right here before, and then right here too. Coming in like this, and right here it's coming in like that. And it's coming in, hitting every front surface point of the raindrop right here. What's going to happen is, let's say here's the raindrop, it's going to create a cone. So it's going to create a cone like this. And that's just for one little raindrop. Now, let's say here's the sun, and here you are. Now let's say it's raining right here in front. So here's the sun, you're in between the sun, and it's raining over here. So it's going to be raindrops like this. Okay. There will be white light coming in from the sun like this. It's going to be hitting all of these raindrops. And each of these raindrops are going to form cones, a spectrum cone. So, let's say this raindrop is going to have a cone like this. This raindrop is going to have a cone like this. This raindrop is going to have a cone like this. And then this raindrop is going to have a cone like this. And this raindrop is going to have a cone like this. So, if you look at this top cone, the light that's right here at the bottom of the cone, the bottom center of the cone, comes to your eye. If you look at this cone, the light from the right side comes to your eye. And the light from this cone, the left side of it, comes to your eye. And the light from this cone, the right side of it comes to your eye. And the light from this cone, the left side comes to your eye. Now these cones do have light that extends out in every direction that the cone extends out to. But it just so happens that the cones have light that goes to your eyes along this arc. if you was to imagine the cone from this raindrop, no matter which way the light extended from the cone goes, if it goes like this or this, no light or ray from this cone, the spectrum cone, goes to your eye. Just think about that. It's all the way to the left and it's all the way to the top. But the one in the middle and the top does have one that goes to your eye. The one to the bottom left has one that goes to your eye. But the one in the middle doesn't. It's too low. And that's rainbows.